Hello, pre-algebra kidlets. Today, we're going to review slope-intercept form, which you guys looked at in class in December. We're going to do some graphing lines review and a pro tip for this video, 8th graders. Do not try to skip around. There's lots of instances of me hitting the next button and some words flying onto your screen, and you're going to miss them if you keep skipping around. So don't skip around. And you should have gotten some notes that look like this from whoever is subbing your class this period. So at the top, it says that the slope is, and you're going to fill in the rate of change. We call that the rise over run, which means how far up it goes divided by how far to the right the line goes. And we'll take a look at that a little bit later also. You've also got a y-intercept, and that's going to be where the line crosses the y-axis. So this formula that we use that we call slope-intercept form, we use the equation y equals mx plus b, and that's going to be a formula for the equation of a line using its slope and its y-intercept. That's why it tells you the slope and the intercept. That's what it's named after. It's very nice like that. So we've got our equation, y equals mx plus b. And the two numbers that you're going to see change a lot are the m and the b. So the m represents the slope of the line, and I made it have a slope because your slope is the part that can go up and down. Mx plus b, and b is going to represent your y-intercept. That's, again, where the line crosses the y-axis. That's the up and down line on your graph. The y and the x in this equation are both going to be variables, so they're going to change depending on where on the line you are at. You don't need to worry about them quite so much in this equation. Once you've got it in slope-intercept form, the things you're looking at are the slope and the intercept. At the bottom of your notes, it should look like this, and it's going to tell you your steps for graphing a line. So the very first thing you want to do when you're graphing a line, in this case, we have the line y is equal to negative 3x plus 2. That's right here. I also wrote it at the bottom of this PowerPoint in big letters in case that was hard to read. You're going to start by placing a point at your y-intercept. And as we said in the last section, that is y-intercept. That's the plus b at the end of your equation. So in this case, our y-intercept is going to be this plus 2 guy right here at the end of our equation. So we're going to put it at our y-intercept, and that's going to be positive 2 because the y is the up and down line, and then positive 2 is plus 1 plus 2. It goes right here. All right. From that point, you're going to count out the slope to find the next point. But you want to be careful about positive and negative directions because your slope could be going up. It could also be going down. So in our example, we've got y equals negative 3x plus 2. We've got negative 3 as our slope. So we're going to have a negative slope. And I told you that slope is equal to your rise over your run, and we only have a negative 3 here. So one tip I want you to remember over here on the right is, for example, our slope is negative 3. Any number by itself is the same as that same number divided by 1. So if it does not say divided by some other number, we can infer that that number on the bottom of the fraction needs to be a 1. So we're going to have our negative 3, draw our fraction bar, 1 on the bottom. So our slope, our rise is negative 3. So if it rises by negative 3, that means that we're actually going to make that line go down. Going up by negative 3 means you went down 3. And then our run, the amount we went to the right, is positive 1 because there's nothing in front of it. So it's positive. And so that means that we are going to be moving it to the right. So if we take our original number here at 2, 0, and we move it down 3, 1 to the right, our next dot needs to go right there at negative 1, 1. So that's where we would draw our second dot. The third thing that we do is we connect those 2 points to form our line. We would just draw a line in between those 2 points. It continues off in both directions infinitely. Isn't math beautiful? Okay. Go ahead and turn over your page. We're going to write some equations for each of these lines in slope-intercept form. And I put a tip here at the bottom of the screen because some of my 8th graders like to not listen to me and think they can get all the information off the sheet. And if that was you, you're missing out. So our first equation, the one on the left, we need to figure out our slope-intercept form. So when we see our line, there's only two things we need to find: our slope and our intercept. And you can do those in either order. I personally like finding the y-intercept first because it's easier. So when I look at this line here on the left, I'm going to see that the point where it crosses this y-axis appears to be at -1. So -1 would be the end of our equation here. And we also need to find the slope. And we can find the slope between any 2 points. We've got a point here and a point here. So we can see that in between these 2 points, we go down 2. So that's -2. And we go to the right by 1, 2, 3, 4, 5, 6. So that would be -2/6. We could also simplify that fraction to be -1/3. So we would get y equals -1/3 x minus 1. And if you're not listening to me right now, you will not have the answer to that question. So tell your friends who aren't listening to me that they should listen to me because the answers are in the video. On the right side of our example here, we've got another line. This line has a dot right on the y-intercept. That makes it pretty simple. And it appears to be down 1, 2, and 3. So that's going to be -3. And when we're trying to find our slope, it's our rise over our run. So up divided by to the right. We've got 1, 2, 3, 4, 5, 6 divided by 1. We could write that as y equals 6 divided by 1x. You could also just write 6 because 6 divided by 1 is the exact same as just 6. So we could say that y is equal to 6x, and then our y-intercept again is -3. On the next page, we're graphing these lines. We're figuring out, I definitely prefer to put the y-intercept on here first because that's the easiest point to plot by far. So we know that we're going to have a spot where y is equal to 0, or I'm sorry, where x is equal to 0, y is going to equal +4. So we go up 1, 2, 3, and 4 to +4, and we would put a spot there. Our slope is -x. We don't have a number there. And in math, when there's not a number in front of the variable, that means that number is 1. So our fraction here is 1/1, and it's negative. So our slope is going to be going down at a rate of 1. So we'd go down 1 and to the right 1. Over here on the right, we've got a slightly trickier situation. It might look similar to that equation on the left, but if you look closely, it says y plus 1 equals 1/4 x. And we need to get that y all by itself. That means it needs to be isolated by itself in order to make that format that we're using, the y equals mx plus b. So in order to get y by itself, but keep the equation balanced, we need to subtract 1 from both sides before we can start here. So if we subtract 1, we'll get y by itself. And on the other side of our equation, we're going to have 1/4x minus 1. Sorry, this is how PowerPoint makes my fractions. 1/4 x minus 1. So again, our y-intercept is going to be -1. And then our slope is going to be a rise of 1 and a run of 4. So we're going to go up 1/4. There are a few special cases that you're going to see in this format that don't look exactly the same. So the first one is when you do not have a y-intercept. You just have something like y equals 2x or y equals 15x, but there's no plus something at the end. That means that that plus something is actually going to be 0. That means there's no y-intercept except the one at 0. So the y-intercept is 0. You start at 0, 0, the origin for this example. Our next one is going to be if there is no slope. That's going to be a horizontal line. It's totally flat. So for example, y equals 4, you would figure out where y is equal to 4, and that's going to be a horizontal line because it never goes up or down. It just stays at 4. And then our last example is going to be anytime your y is not all by itself yet. So you're going to have to manipulate that equation to get the y by itself. In this case, you would subtract the 5, and then you would divide both sides by the 3. It just means y is not by itself yet. You need to do more steps before you can do anything else with this equation. So the next thing I want you guys to do is identify the slope and the y-intercept for each of those examples at the bottom of your page. You can problem solve these with a partner if you would like to discuss it with somebody, but you're going to go ahead and figure out what should the slope and the y-intercept be for each of these. Well, if it's getting near the end of class, please ask whoever is subbing your class this period to write the answers on the board, or to let one of you write them on the board so that everybody can see what they are and they can double check their answers. If you finished this early, you superstar, over here I've got a QR code that's going to give you some extra practice. It's like a math lab where you can mess with the variables and see how the math changes, kind of like we do in science class. It's a little bit easier than the science labs, but I think it does a good job of showing you how things change when you mess with the different variables. Like what happens if you change the b at your equation around? What happens if you change the slope around? What's happening? You can see in real time how that line changes, and I think it'll really help it click if you're still a little confused. If you're done early and you totally understood this, you already did your math lab, you can color code these notes. They're really cool to color. I hope you enjoyed this video. Come see me after school if you still have questions on this topic. Have a fantastic day, guys.